Hello Biology 1, this is Mr. B, and here is your first flipped lesson. We are going to start with Chapter 1, Lesson 1, What is Science? So the first question we're going to ask ourselves is maybe what is the definition of science? The way your book describes it is as science is an organized way of using evidence to learn about the natural world. I think that's a pretty good definition here, and the two big main keys you need to look at here are evidence, because when we talk about stuff in this class, we're always going to need evidence to back up what we say. We can't just make statements just because we feel like it. And then the natural world is the other big part, but we'll get to that one in a second. And the word science is also going to refer to a body of knowledge that scientists have built up after years of using this process. So all this, your book that you have, everything we're going to have, it's going to be referred to as science. So to help us better understand science, we need to ask one really big question though, and that is, what is the goal of science? And your book has three pretty good definitions, I believe. The first one being is to investigate and understand the natural world, explain events in the natural world, and then to use those explanations to make useful predictions. I mentioned earlier about natural world being very important because when we look at science class, we can only talk about subjects that can be backed up with evidence. These are things that we can feel, things that we can see, things that we can measure, things that we can touch. So there are some fake sciences out there, kind of like astrology, like if you read your horoscope, if you see all those ghost hunting shows on TV, those are not real science. There's really no proof behind anything that any of that stuff says. So our goal of science is to just look at the natural world and then to make predictions to kind of predict, I guess, how things would react if it ever happened again. So the goal of science, those three things right there. So once we know the goal of science, we're going to start thinking like a scientist. So scientific thinking first begins with an observation. And again, your book describes observation as a process of gathering information about events or processes in a careful, orderly way. So when we think of an observation, I know I usually just think of looking at something. Well, when you're a scientist, you're not just going to look at something and be like, "Oh, I know everything that's going on." You actually have to take careful steps to determine what you're actually looking for. So, first step is an observation. And then the next step is actually collecting what's called data, and that is just the information that you gather from your observations. So there are two types of data that we are going to look at. The first one is quantitative data, and that's expressed as numbers obtained by counting or measuring. So that would be like length, distance, how heavy something is, those types of things, where we can actually use an instrument to measure what it is. So temperature would be another example of that, just using a thermometer. So that's quantitative data. If you think of math class, you quantify things, and that has to deal with numbers. And the next type of data that we have is called qualitative data, and that's descriptive, and that usually involves characteristics that can't easily be measured. So when we think qualitative data, that would be how smooth something is, how rough something is, maybe how hard something is, how soft something is. There's no real tool to measure any of those things. So qualitative kind of sounds like quality if you break it down. So that would be how you remember that. Quantitative would be mainly numbers. Qualitative will be descriptive words, almost words you would have to use in English class when you're writing a descriptive paper. So we now have our types of data. So once we have that data, since we're scientists now, we're going to use that data to make inferences. And an inference is a logical interpretation based on prior knowledge or experience. That's kind of a tough definition. So in other words, it's almost using the evidence or the data that you have just to make a decision. It's not using your personal experiences or what you think is right and what you think is wrong. It's just using the evidence to kind of make a logical interpretation on what we have seen so far. So when we're scientists, we can't just make something up because that's how we feel like. We have to use the evidence all the time. So the next step after making an inference is to make a hypothesis. And a hypothesis is a proposed scientific explanation for a set of observations. And another kind of quick, easier definition would be an educated guess might be one. So that is kind of the next step after an inference. An inference is kind of just your initial thinking, and a hypothesis is almost putting it in kind of an official form to be tested, because a hypothesis needs to be able to be ruled out or confirmed. There's probably been millions of hypotheses made in the scientific world, and a lot of them have been ruled out as being wrong. So there's nothing wrong with being wrong. It's just we would never know what's right if we weren't wrong. So that's a big step, is making a hypothesis. And when we propose a hypothesis, it must be able to be tested. And we test these by performing controlled experiments or by gathering new data. we're going to talk a lot about controlled experiments. It's probably going to be in your next lesson. And again, you already know how to gather data, whether it's just using your quantitative, your numbers, or your qualitative, the quality of things. Oh, wrong way. Okay, so then science is a way of knowing. Again, this is just a quick review of what we just talked about. Science is an ongoing process that involves asking questions, observing, making inferences, and then testing hypotheses. So if you guys have any questions, feel free to re-watch this video. Let me know since we're doing it in class, or just write them down and we'll address them in a second. So thanks for paying attention, and we'll talk about this soon.